Okay, again, welcome everyone to our webinar about Creo Advanced Assembly. I'm Dries de Sager, and together with my technical colleague Stefan Vlaming, we will host this webinar about advanced assemblies. This webinar is ideal for everyone who's struggling with large, complicated assemblies or who want to optimize the design methodology to save a lot of design time and reduce the risk of rework and scrap. So nowadays, products are almost always complex in its own way. So this topic is super relevant for a lot of companies in the industry and so for a lot of our customers. We will learn today from Stefan how to take control with top-down design, skeleton models, and the master model approach in Creo. But before we dive in, I want to explain you a little bit about the GoToWebinar environment. There is a question bar at the right, which you can unfold by clicking on the question mark. If you have any questions during the webinar, feel free to put them into the box. And at the end of the session, we will see how much time's left and probably answer some of the questions. If your question wasn't answered during the webinar, we will come back to you afterwards. And then one more remark before kicking off. We would also like to invite all of you to our user events in the Netherlands and in Belgium on the 3rd or 5th of June. At these events, we will take a closer look at the latest innovation and practical tips around PTC technologies with guidance from our technical experts. It's mainly aimed at Creo and Windchill users, since the sessions will mostly focus on technical content. Some topics we will tackle are generative design, composite module, weight distribution, and simulations. Feel free to bring some colleagues along. You will find the invitation with more details on our website if you go to the event page or by scanning the QR code. So we hope to see you there. And then the agenda for today. Stefan will talk us through what is top-down design, efficient management and collaboration of large assemblies, and to conclude, design automatization with a master model approach. So Stefan, please go ahead.
Thank you, Dries, for the introduction. So let's have a deep dive into top-down design and advanced assembly module. First of all, what is it? What is top-down design? Well, it's a central part that you kind of create, like you see here. The blue part is the skeleton part that you create to drive that lawnmower and to drive that geometry from that. So this is something that you build up on the go. It's not that you have to create that all up front. It's a step by step while creating your module. It also has the ability to, before even you start with a part, you can already create that. So what you see here on the left is that that circle that defines the wheel diameter. That line that starts from the center up is defining the brackets and so forth. So we build up the geometry, what we want to design and what we want to incorporate in there. Like here is, and that's a choice. It's a circle. It's just a diameter that we define. We did not define the depth. Right? Maybe the depth is not an issue. That's depending on how deep and how in detail you want to do that. Mostly we limit to interfaces between components. And so components that are linked to each other, and that's the main goal. If you have some more details, that's just in that part, and that's not necessarily needed for other parts. You can just create that in there. We'll see that in a moment as well. Yeah. And a third big item which we can tackle with top-down design is, of course, larger sub-assemblies and working with multiple people together. Here's an example of a knife that is developed, and the lead designer defines the skeleton with some lines in it, and then different people one works on the handle, other works on metal parts, the cutting part itself, and different people work on different parts, which in the end results into an end part which is designed by multiple people, because why this works, because they're using the same interfaces. Like the holes, the mounting holes are the same position in all parts because it's all derived from my skeleton. And so that's a little bit the trick that we try to do with top-down design or with skeleton design in Creo, especially. Where do we use skeletons? So there are different methodologies, different reasons why we could use skeletons as well. First of all is create interfaces between components. Like you see the transmission here on the bottom. On all those housing parts, we need openings for the central axis. And so these are needed in multiple parts. We need that at the exact correct position, but also more in detail, like the red and the blue part. You need bolting holes between those two or other things that are common. And you want to keep that 100% correct. It's hard to maintain those references if you don't work with skeletons. Placement references, like you see here, that factory layout, different parts are different sub-assemblies from very in the beginning. Maybe that can be, there's a little bit working together with the second one, with the space claim. And maybe you just start creating blocks that represent machines on a coordinate system, and the coordinate system and where all the position, all the coordinate systems are derived from our skeleton. So it's very quickly, very fast in the beginning, building up a structure, and later on, those building blocks can be replaced by actual machines or products or whatever you guys create. Yeah. Also in surfacing, creating common surfacing between parts. Imagine that you have to design that side, fender, front, rear, and door in 3 separate parts, and maintaining the nice lines in it and nice gloss in it. That's, in my opinion, nearly impossible to do that without skeleton. So what we do here, we create that in one part. So that is one surface that goes through the from front to back, and then we cut that out for a section for the door, a section for the fender and front, and rear fender. And that's also a different way of working. And of course, also create motion. What this example done here is that we start creating the geometry that we want to design in the end by just creating lines. So we create a circle again that rotates. So this is just based on circles, line, points, axes, where we create that mechanism in. So you can test your mechanism before you even created one part, and then copy those lines or those circles, whatever you need to into a subpart, and that subpart will use the same references to create something like that. Yeah, cool and easy way to test your mechanism before even one part is designed. Yeah. And the main purpose of most of all these options is, of course, push your changes that you have very fast downstream, so that all parts are up to date and that you can maintain a good assembly. Benefits. So on the left, can we do that without, is that possible without advanced assembly, without skeletons? Yes, but it will be way harder to control that. Now you see here on the bottom you have 4 parts. They all have common references. So what typically, if you don't use skeleton design, what's happening? First you create part A, then you create B. B is then using hole position holes. I'm just imagining something, positioning holes of A. C is a reference to that as well. So yes, you can do that, but yeah, I have only 4 parts, and you see how complex it could get. Imagine then later on that B needs to be replaced, or are changes, and you don't necessarily see where all the links go through. which we have on the right side, is a way easier structure. So we build everything that we need for the different parts. We build a skeleton. We copy the links between the 4 parts, and we can work with that. If later on maybe B needs to be used in another assembly, we can break this link. Because this is created in one feature, in a copy geometry or merge inheritance. That's the 2 features that we use to copy from our skeleton to our part. We can just block this. This can be hidden this link can be hidden in a sketch. This can be in a reference that you use, or an extrude depth. It can be references like that. So this is very dangerous for creating circular references, or even have a distorted order. The idea that you have to press 2 or 3 times regenerate until your part gets the correct result is also often this case. Yeah. This is not only in Creo that this happens. This is for all CAD systems. It's the same. All parametrical CAD systems is all the same issues that they have to solve. Yeah. So to conclude a little bit, and then let's dive into the tool itself. What's the difference in bottom up or top down? Top down design, you start with individual parts, and then you create those assemblies and you start assembling in different parts. We all know that. It's easier for standard parts or reuse. But you have limited update functionality. You have to know, if I'm changing this part, I need to change that as well, or have interference checks more often, things like that. The knowledge is in the user's head. And this is cool for and easy for a little bit smaller assemblies that most of the time one person works on. If it gets bigger and more people start to using it, then it becomes a challenge. So here we can start with an overall layout. So we have an idea where we're all working to. The individual parts are derived from that. That doesn't mean that you cannot just assemble parts as well, standard components and things like that. It's a mix. You have a strong relationship between parts. Like I said, ideal for complex assemblies. And also it changes very fast. And so your master model, your skeleton on top, changes all references to the link parts if needed. So let's have a quick look into Creo. And I will just start with a simple example. I'm just going to make 2 flanges with bolt holes together, 6 holes, 2 plates. That's it. So how do we start that? First of all, I created an assembly. It's impossible to create file new skeleton model. We have to make that in context. So I will create a skeleton model like you see here. You'll see that he automatically takes the name of the assembly underscore skeleton. So in naming in your bill of materials, see that they are listed together as well. Standard part. And the second thing that you see that it's assembled, it's placed automatically on top. It's always default assembled. You have no choice in that. And it's the first thing that he starts calculating. And that's important. If you change anything there and then you push it downstream, it's the first thing that needs to be calculated. I'll open the part. You can work in context or open the part individually. And let's start sketching some references. So I'll start with a center rectangle, which is my outer shape, another one which is my inner shape, and then I'll use a third one as a construction where my bolt holes will be referenced. Okay, so let's put some dimensions. I want that 500 millimeters, and then the outer one here will be 300, for instance. 20. It's just a little bit sketching and that we need to do here to get some references done. Right? And then you see it also building up from scratch. So it's just a sketch with some points, with some geometry. Point on it. He's referencing somewhere that's needed. I'll just delete one. 20, and then here as well. Come on. Oh. 20. So we have our sketch made, and what I just want to do now is add some points on those intersections, on those endpoints and the intersections. There's something still wrong because it's not centered correctly. I see it because he's snapping to not to my midpoint. Just give me a quick minute. Modify. What? Yeah, it will work, I guess. So what I have is two sketches, two lines, that's it, and some points that define where the holes will come. That's all what I did. Now, if we go into our assembly, you'll see the same coming up, of course, and now we want to create our parts. So again, in context, I will create a new part. Let's call this plate 1. Okay, that's a new part. Because I have nothing in there to place it already, it's easiest that you just position a default. You can work with the different positions, but in our copy geometry that we create later, we have to teach it. Yeah. So I'll do the same. I will activate this part because I want to work in this part, and here in this part I will start creating a copy geometry. That's also, by the way, the easiest way to see if you have AX license, your advanced assembly license running. If copy geometry is grayed out, you don't have the functionality running, and the otherwise you do. Yeah. So I could create that in context. I'm not going to do that because then he creates a link between the assembly and through the skeleton. So it creates multiple levels up. I don't want to do that. I want to create directly a link between my part and my skeleton. Yes, we are also creating a new link, but we can manage it and we can control it much more or easier than just creating direct links. What I want to link to, of course, is that skeleton. That is all default positions, so we'll do using that as well. And now I can copy surfaces, I can copy chains, bodies, and references. What I need to do here is I want some chains, so I want that curves. So I'm selecting the outer one. So we'll make in the first end plate, and so the closing plate. And we'll start selecting some references, some points that we want in there as well. So that is my copy geometry. Now if I look into my part, you'll see that I have this left, and based on that I can create my part itself. So let's start with the extrude. Using that projection lines, I can very quickly select everything. That's okay. And here we want to just create some through holes. So I'm using those points as well to place my holes on. I will just quickly make it in one feature now. You get the idea. And maybe change the diameter to 12 millimeters. Okay. This is our flange. Here we did not choose to add the thickness. We'll do that. We'll add that later on. Maybe 20 millimeters thick. So that's our first plate that is referenced to this assembly. Close it up. My skeleton I will go to the assembly again, and you see my first part. Yeah. So my second part is roughly doing the same. So I will create a new part, plate 2, also default positions. And in that second part, I will do the same again. I will activate it, copy geometry again. So an external one, and then selecting what I want. Chain, which is easy to see as well. Why we're using this window here? Why, if you go into external, it automatically opens this window? Because I have those lines here in my main window 2 times. I have it for my skeleton, and I have a copy into my plate 1. And therefore, it's easier to go into that window. So I see only what I can select in there, and only directly linked to my skeleton. Otherwise, there's a possibility that we again start making references to other parts, which is of course unwanted. So again, top project, close that up, use. So that's my second plate. Of course, no holes in there. -30, for instance. Okay. And now I want to place the holes. So that's just one little disadvantage that we have. We are copying just geometry references. So I cannot use those points as a pattern reference, because it's just clear points that he copies and no feature information. So in this case, what we'll do is we'll create here a sketched pattern on those position, and now I'm resetting the same points on the same position. Okay, and now I can quickly tell the system I want a standard hole. I want it to be M10 through all, and of course my threads, for instance, also through all through threads. Okay, so my holes are created, my plate is made, and I have my assembly. My assembly of 2 parts. Now I can easily change that. So like I said before, if I now go into my skeleton, it's just one sketch that drives everything. So if I'm changing that 300 to 500 as well, maybe model regenerate, you will see that all the rest will follow. Yeah. Like I said in the beginning as well, we don't have to put everything up front in there. It's something that we can create on the fly. So if I maybe that second plate, I want that depth as well in there, no problem. I will open a skeleton. I will create a datum plane with an offset to maybe make it, I will make it 70 so that we clearly see it that this will be a big part. So that's my datum plane. I could give that a name to make it clear for everyone else. And if we now go in here, I of course have to add this to it. So I will do an edit definition. I will add a reference. And if I display my datum planes here as well, I can select that datum plane. So add the datum plane to my selection. It will be on the bottom here. And of course, now my extrude can be referenced instead of with a thickness of 30 up to that datum plane. So this is depending on what I need, how I will construct it, and it's something that is live and evolves while you do that. Yeah. Of course, this is a very easy part. I would probably never use that on just 2 parts, but it's a good example to see how things are built up and how we work in that. So let's have a look at a little bit more larger assemblies, and also where you can work together. That's a different way of working. So that has some benefits as well. So first of all, faster load times, because if you tend to work top down, you have the tendency to open your total assembly and start assembling, working from there. Although you're working in sub-assembly, you want to see what is in the neighborhood or what the references are. If you more tend to work with a skeleton structure, you have all the information that you need to create your part. You have maybe some reference parts, some surfaces copied around you, and you don't need all your total assembly open. So therefore, we can have faster load times. There's also some tools to manage internal relationships. So some settings that you can block making general references, only copy geometries or things like that, and that's a possibility. And also working with published geometry. Published geometry is in larger teams where it's harder. I will explain it in the tool as well. But if you have a large complex skeleton, it's harder to define what you need in your assembly. Because maybe I'm not so familiar with it, and then it's the general designer that defines a publish. This is for your project or your sub-assembly or your team. I don't know. Yeah. Let's have a look as well. Let's open that boat, that catamaran. So this is my assembly. There are some things predefined. Of course, it would take us way too much time to create that all in one. So let's have a look at the skeleton. That's our main skeleton, where they created, first of all, some curves, some datum planes where they want what, and how it is built. So these can be features. So this can contain extrudes, solids, surfaces, curves, points, whatever you want. But that gives you an idea on how things are built. So we have here like datum planes as well. That divides the partitions to add strength into our assembly. It's built up like that. And on the end, on the bottom, we'll see that we have in the footer, these days in the footer, those are those publishes. So what a publish is, and I'll just quickly delete it because what a publish is like, I need this information, or my colleague needs that information for this project or for that part of the boat. And you see you can make here multiple ones, and every published geometry can contain the same geometry multiple times. So there's no limitation in that. Let's create one here. So we create a published geometry because in the hole that we created, there are some dragger boards that the opening for the dragger boards that are not yet in there. So we'll start with selecting some surfaces. It's the same menu what you saw in the copy geometry just before, but it's a different way of constructing. Maybe I need that curve as well for some things. And there's a datum plane on there as well. So I'll use that datum plane for a direction, a reference for the cutout. So I assembled my information that I need, and of course I can, it's easy to rename that. So it's easy to rename that so that you have an idea what you're looking for. Yeah. So this is done typically by the master designer, a person who manages the skeleton and who controls it. And then now the next step we're gonna do by it's the user and that maybe finishes the parts and needs some more information. A little bit more structure as well. So we can make very complex structures or very easy structures. It's depending on what you want. Typically, so one assembly can have one skeleton each or multiple skeletons, depending on what you want. So this sub assembly has its own skeleton as well. So there's a skeleton here. you'll see this is just for the body, what they done here if we open it individually. So the main one was the main surface. What they added here was opening for different openings and also for the windows. So they added some curves and opening for the windows. This is only information that is needed in that sub-level. So you can add multiple levels down, more downstream, and add information downstream that is not necessary for the top level. So that is also a very cool strategy or methodology that we want to work with. And then, so the copy geometry goes from that skeleton to there, and this skeleton to that part into here. Yeah. I understand that maybe is complex now, but that's something that we also see in training. Yeah. So let's make a copy geometry in here as well. I'm activated the part, and just like I did before. The difference now is that I'm gonna again click an external one, but also a publish one, which I can not individually select. I have to choose what somebody else has created for me. Now the link will be to my skeleton. So this one will be reference to that default, and I will select a publish. I have two ways of selecting them, or I go into my second part, which is normally open, and I select in the footer what I want, or I can select it here what I want. So I want those rudder items that I've just added to it. Okay. And if I now open the part, I have enough information to finish what I started here. I just added this copy geometry and that plane, the curve, and the surface. So quickly finish our part here. What I'll do is I'll trim this part with that surface. So we have the opening in there. That's what we wanted. And maybe in the trim, I will say that I don't need that surface anymore. So it's hidden in one go. Now select my surface, create a mirror around my plane, center plane. So that's my geometry. Let's merge it together and let's solidify it. And this side and that side, let's merge it and just give it thicken on it 27 to the inside. So my hull is created. I can build that, and this is just built on these two or three copy geometries that I have here. Yes, we can add more information, more functionality, and maybe we need to have cuts made here or features added here. That's only relevant for this. And maybe we have to go back to our skeleton and add some functionality in there as well. Yep. Let's close this up. Now I just manually selected, so this is my skeleton again. I manually selected what I needed. So I manually set it to a publish geometry. There's also a possibility in my assembly, disassembly, or in general, I can set my reference control. So with these settings, I can now I can create references to all components, but I can limit it. So in the larger companies where we work only with skeletons or mostly skeletons, and we can skeletons and layout models, we can limit it, and not all geometry, but maybe only published geometry. So now it's very limited, and it's depending on what you want to do, what your preferences are, and how you work inside the company. So this part is done, and so the body is done. Let's do another part. Let's go a little bit. We need a fresh water tank that needs some designing. I'll have a section prepared, and we see the geometry here on the bottom. So what is already created is those baffles. There are also already created some copy geometries in there. so that you can see how this works. So if I'm opening that, what you see here, and that's predefined a little bit, is an offset from the hull. So I have it a little bit smaller than the original, and it needs to fit between those um, two planes where my the stronghold of my ship is also made of. So I need to fit something in there. We have also a predefined sketch between those two with a little offset between the plates and between the sides. Yeah. Let's quickly create something. So that's the idea, that I may be only opening this part because all my information I received from my top skeleton. And I don't just need this information. I have enough to create that part, and I don't need anything else. That's the idea. So large assemblies that you need to open, so a little bit easier that you can work with. So I create a solid over it. The other ribs that were created were in a body. So I will just subtract this surface, remove material, not the inside, but the other side. I want to keep the top side, and not only on the main body, but on all bodies where I can make the cut in one go. That is what we have. Now make a quick shell of everything 8 mm, for instance. And we have fuel, the tank water connection cutouts already pre-made. -8 because of our thickness. Okay, and maybe this part is created and ready to go. In the end, of course, those surfaces, we don't need them anymore. We can hide them, or we can also put them on layer that you don't see that because this is your end part, but it is derived from our references that we have copied. If we now look back into our main part, and we see the part done. Now let's go back to a change in here. Maybe later on in the process, we'll see that that reinforcement plate, it needs to be moved for whatever reason. We need to relocate it a little bit. And this is, of course, derived from a datum plane, like we have here. So I will just change that. If you work with correct names, you can easily find this. I will 1118 millimeters instead of what we had before. Model. Now, what is also a possibility, I'll go back to my part here, is that the copy geometries that we make, I will just do that. We can handle that update control. So if I now just put regenerate, he will automatically calculate. Maybe I don't want that. I don't want that on everything because then things change that I have no control over. You can do manual update, but that you have to control it manually. But what I prefer is a manual update with notification. So if I'm doing this, I get a warning from it. Let's now go to our assembly and start regenerating everything. That takes a little bit of time. And of course, a lot of features can be involved in there depending on what I need. We're almost there. So I will just quickly collapse everything. It jumps to the last part. And I will quickly collapse everything. And now on those triangles and on the item here, you have a rotate placement. Oh, the little triangles, I can scroll down. It's in this assembly, in that sub assembly. Another few sub-assemblies down, I'll see that's it. It's this part, and it's that copy geometry that is out of date. Yeah. So I have something wrong there. Now I have two choices. I can say to that update control again, yeah, just update. Now do it manually, or I can have a look and show the differences. So this is very cool. I can isolate that. What is changed? Maybe changing that gray one to a blue curve. So the first one was a blue. I can show one or another, depending on what I want. I have again a look in my complete assembly and what are the changes. I can even use design exploration in here to see the effect before I go forward, or I can just push update. And if I start updating it, you'll see the part is now interfering. If I update that surface, the sketch will move, everything will move along, and I have no interference anymore. Yeah. It could be possible that we have some other issues here, but now because I had a warning, I can investigate what is going wrong and where and how we can fix it. So, and in that way, we can control our part and create a full ship with all references in there, all what we needed in a linked and with multiple persons. And that's if you want to have a short design period, you need to work on such an assemblies with multiple persons. Otherwise, that's maybe too long of a lead time. Okay, so let's go back. Our third item that we had is, of course, a design automation. It's also part of advanced assembly and how you can work with this. So it supports of family tables, automatic placement. You can configure what you want. You can generate variants. But again, let's have a look at the assembly. Let's open our top assembly. So this is a very simple example of a gate where we can work with. Again, you see here the skeleton on top. If I open this up, it's again some sketches, some geometry, also some datum planes where, in this case, where the hinges are. Some axes you will see as well, and where the hinges are positioned, and how this is built up. Again, this information is something that we build up in our skeleton and that we can work on. The only difference that we done here is that we don't go in our skeleton to change something, but we worked with Pro Program. It's something that exists already a long time in Creo. It's very powerful, not that complex. In the end, you have some a commando or aid, something that you need to learn. But once you get the hang of it, you can do great things. And the main interesting thing is if you push regenerate, that you can have a discussion of a question. I will just select everything here, done selection, and now I'm into questions that the system asks me what I want to change. Maybe my gate opening, I want that 4,500 millimeters. Do I want the opening in the center? Yes or no? So if I'm selecting no, it will be not in the center. So I have the next question. If I select yes, he will skip the next question. We'll see that in a moment as well. The code is a big word. So I'm pressing no because I want on the left a door panel of 1.20 meters. These hinges are a manual hinge. Maybe I want an automatic hinge, so I will press 1. The type of paneling, so this is an aluminum paneling. Let's choose, for instance, 3. So these are choices, questions that you have to fill in. depending on what you want to do. I will skip some, and maybe the floor is a little bit uneven and I want one side a little bit higher, not 1500, 150 millimeters. Left side is opening first, and you will see that after some regeneration, he will build up that model and you have an idea on how this is built. Yeah. So you see that added motor, automatic gate opening. You see that the hinges change. It's only one hinge on top and not longer on the bottom. And yes, we can add a mechanism in there, so that is even possible to do that. And if you're not happy with that design, right, so maybe this is not 100% what you look for, well, you just press regenerate again. You enter, you select maybe what you want and not everything. That's your choice. Maybe that height difference I want to address a little bit. And that's a choice that we have. So maybe make it 50 and 100. I'm just changing something and he will only calculate that in there. So now my height is a little bit different. So this is quickly to generate some geometry. Now let's have a look how this is built. So what I've done is in my top assembly, we have added a program. That's a little bit of code. I will show how it is built. And this is just one text with a little bit questioning. So every part in Creo has kind of already adding the program in there. I'll explain if we go a little bit down. You see here, there's that's probably one of the first here, the datum accesses at feature number 6 with these information and add, and that is feature number 7 with this information. That was the A-axis, this is the X-axis. So every part that you create, every extrude that you create ends up in here, and that's how Creo has that parametric build up in there. What we just did, we added an input value where I have some parameter value with the value that I now entered, and that's the question that he asked me. I have also an if functionality that I have if opening model is no, and like I discussed here, then he can ask this question, otherwise he goes forward. Then we can create some relations in here, depending on what I want to do. If this type is selected, then I want this distance there and there. We can create this the same way. And this is then that execute functionality is a way of pushing information to subassemblies. So I execute some information to my gate. I'm executing some to different parts in my assembly, where I then pick that information up again, and I can use that in parameters and references and doing that. Again, this is something that we build up step by step. It's not you have to create all the questions, you have to create everything up front. No, this is something that it grows. And you have two strategies. You could put everything in there that you want. Now here we discussed or we decided not to add the door, the ring for ringing or lights in there. That's not an option because every client wants maybe there are 100 versions and they don't want to put everything in there. So you have to choose between an 80% BOM or 150% BOM, where you just put things out. Yep. A third option, the last option that we have in there as well, if I press regenerate again, I can do this based on a file. As a quick example, I created it's now just made in Excel, but you get the idea. Maybe this is a website where you have some things that you have to enter. These are the same questions. So in the export, these parameters are linked together. And so the parameter name and the value is derived from my first page. and this is just written in a text file somewhere on disk. So if I now do a read file and I want, for instance, client underscore a txt, I want this one loaded, then he will just load those parameters in there and he just starts calculating. So this is maybe on an options and variants, what a client wants or what a client wants to change. So if I do the same, I can read whatever file I want or whatever question I have based on our website. It's even possible to automate that in a process so that Creo runs in the background, just generates this and saves this file. So the idea is here, this is our master model. We generate what we need and then we make a copy of it. That client has ordered this assembly and this bill of material with these parts on these lengths, and then we make another one. That's a little bit the idea. So I give the word to Dries back.
Yes, thanks, Stefan, for the explanation. But before we answer some questions, maybe just a small word also from a commercial point of view. All the functionalities shown today are part of the Advanced Assembly extension, which is part of Tier 2, which means it isn't in the basic Creo Design Essentials license, which is Tier 1. In terms of getting the knowledge to all of you, we suggest doing a one-day training or one-day CAD consultancy with us for those who are interested in advanced assembly and or for program. Right now, there is also a promo until the end of June for AAX. So if you're interested, please feel free to contact sales if you want to know more about it. And then maybe some questions. First of all, I'm going to answer a question about whether the presentation will be shared. Yes, the presentation will be shared, and we also recorded this webinar, so you can review it afterwards. So that was the first question, and maybe the second question, Stefan, I'm going to direct it to you. What happens if you remove things from the skeleton?
If you start removing, then your copy geometry will just don't have that items in there, will fail. And the geometry that comes behind it will fail as well. So that's something that you have to go through. It's depending on your assembly and what you're doing. So if you delete a line and the line is not copied anymore, some that geometry will fail. But that's something that you failing is not always bad. I find it interesting so you see the effect as well, what you're doing.
Okay, great. And then maybe a second question, how can you reuse parts that have copy geometry?
Like I will didn't indeed not go too deep in there. I will just go back. So what the third option is, if you start reusing parts, you have also a no dependency. So hereby you break the link. And yes, it can be restored, but not that easy. Now broken is broken, and we use that to another assembly. So it's not anymore linked to this assembly, but that means that the geometry that is imported, I cannot change as well. So it's a little bit in between. Before I worked with a company that the moment that you release, you break all dependencies. Because the changes that you have done are very slim, are very small based on your form fit function. There are very small changes anymore, so the chances that your skeleton will change later after release are existent to none, almost none, and then you have, and if they are, they have to look and do that differently.
Okay, great. I think we're gonna end here because we don't have time to answer all your questions right now. Otherwise, we will run out of time. Some are also more case specific, so we will come back to you personally after the webinar. But before ending the webinar, we would like to send out a quick poll about what you thought about AAX. So are you already using some functionalities, or are you struggling with larger assemblies? Or do you just want to know more about it, or isn't it useful at all in your company? So please give us some advice how you could use or how you could get interested in AAX. So for now, thank you very much for your attendance, and we hope to see you next time. If you have any further questions, feel free to reach out to us. Thank you very much.